All right, the focus question for today is how can I use the geometric mean between two numbers to solve right triangle problems. How can I use the geometric mean between two numbers to solve right triangle problems? The geometric mean between two numbers. Is the positive square root of their product. And product means to multiply. Very good. Multiply. The geometric mean between two numbers is the positive square root of their product. So if you're asked to find the geometric mean between $12 and $15. All right, the geometric mean between 12 and 15. So the geometric mean would be equal to the square root of 12 times 15. Which would be equal to the square root of 180. Which is approximately 13.42. The other way that you could see the answer, the square root of 180 is the same as the square root of 36 times the square root of 5. 36 being the largest perfect square that goes into 180 evenly. The square root of 36 is 6. So you could see this as 6 times square root of 5. If you put 6 times the square root of 5 in your calculator, these two values are equal to each other. Find the geometric mean between 1/5. Between 1/5 and 60. So the geometric mean is going to be equal to the square root of 1/5 times 60. Isn't that the square root of 12? 3.46. The square root of 12 is also equal to the square root of 4 times the square root of 3, which simplifies to 2 radical 3. These are both the geometric mean between 1/5 and 60. Those two are the same as each other. Questions? Look at the top of 538. The altitude. Drawn to the hypotenuse. Of a right triangle creates two more triangles that are similar to each other and to the original triangle. The altitude drawn to the hypotenuse of a right triangle creates two more triangles that are similar to each other and to the original triangle. So if you draw a larger right triangle, call it ABC, and draw an altitude to the hypotenuse. So it's going to go from the 90-degree angle to the hypotenuse. It's going to intersect the hypotenuse at 90 degrees. And call that point D. That altitude created two more triangles, two more right triangles. Those triangles are similar to each other and to the original triangle. Now, if you want to write a similarity statement here, when this altitude gets drawn, it created two more triangles. Do you see how it also created two segments in the hypotenuse? It created a short segment and a long segment. This altitude is always going to be the longer side of this small triangle, and it's going to be the shorter side of this bigger triangle. Okay? And you can use that when you write proportions here shortly to solve for missing segment lengths. All right, but for right now, we're just going to write a similarity statement. All right, so we'll call this small triangle ADB. And I'm calling it triangle ADB because I'm going short side, long side, hypotenuse. And that triangle is similar to triangle short side, long side, hypotenuse. So that's going to be triangle BDC, which is similar to triangle ABC. Short side, long side, hypotenuse, ABC. Does everybody see that? Any questions? Okay, look at the top of page 539. The altitude drawn to the hypotenuse. Creates two segments. The altitude drawn to the hypotenuse creates two segments. Just looked at that. The geometric mean of those two segments is the length of the altitude. The altitude drawn to the hypotenuse creates two segments. The geometric mean of those two segments is the length of the altitude. So in this right triangle, if you draw the altitude in here to the hypotenuse, it creates two segments. The geometric mean of those segments is equal to the length of the altitude. So in this case, x is equal to the geometric mean of 5 and 20. So x is equal to the square root of 5 times 20. So x equals the square root of 100. X equals 10, doesn't it? The length of this altitude is 10. And now with that, you can solve for y and z. Because you've got a smaller right triangle here. You can do the Pythagorean theorem. You've got a larger right triangle where you can do the Pythagorean theorem. Or you can set up some proportions. This side y is the shorter side, or I'm sorry, is the shorter side of this big triangle, isn't it? So you can set up proportions or you can use the Pythagorean theorem. I'll do the Pythagorean theorem for y first. So let's do 10 squared. 10 squared plus 5 squared is going to equal y squared. So 100 plus 25 equals y squared. 125 equals y squared. $11.18. can now do the same thing to find z. All right, 10 squared plus 20 squared equals z squared. So 100 plus 400. And the square root of 500, 22.36 is equal to z. Any questions there? Alrighty then. Let's see. The last type of problem is when you're going to be given the length of the altitude, but you don't know the length of one of the two segments. So take a triangle like Alright, so this 15 right here is the altitude. It's equal to the geometric mean of this piece and the 5. But you don't know what that piece is called, do you? You don't know how far it is. So, if this whole hypotenuse of the big right triangle is equal to z, then what would this portion be equal to?
Z minus 5.
Excellent. That's going to be z minus 5. Now, we also said earlier that the altitude creates two similar triangles. This is where similar triangles and proportions will make it easier to solve for this, okay? This 5 is the short side of the small triangle, and the 15 is the long side of the small triangle. So if you write a proportion, small side to long side, all right? The small side of this small triangle is 5, and the long side is 15. So you can do 5 over 15 equals the small side of this top triangle. The small side of that top triangle is this altitude. So that's 15 over the long side. You can call it z minus 5, or what else? Can't you just call it a variable? Okay? You can just call it a variable if you want to. So call it, I'm just going to call it x. So crisscross multiply, you're going to get 5x equals 15 times 15.
Why don't you do the minus 5?
I don't know.
You just don't.
I think your 5x is going to be equal to 15 times 15, which is 225. So if you divide by 5, x is going to be equal to, is it 45? All right. So this piece right here would be 45. And what would z be equal to?
50.
50, good. Now, once you know what this piece is, okay, you can do 15 squared plus 45 squared equals y squared and find that hypotenuse. You can do 5 squared plus 15 squared equals x squared and find that hypotenuse. Okay? Or, if you want to write proportions and crisscross multiply, you can do that as well, because all three of the triangles are similar to each other. So it's your preference. Does that make any sense? Let's write a couple proportions before I give you your assignment. In this, let's see if we got enough information here. You got a short side and a long side. You got a short side and a long side. Okay, in the big triangle, you got a short and a long, you don't have a hypotenuse. You got a short, a long, you don't have the hypotenuse. Yeah, you're going to have to use the Pythagorean theorem. You don't have enough information yet to write proportions. Okay? So you're going to have to do 15 squared plus 45 squared equals y squared. And you're going to have to do 5 squared plus 15 squared equals x squared. Do the Pythagorean theorem twice, solve for x and y. Clear? All right, on page 541.